Hello, and on behalf of our Research Institute, I'd like to welcome you all here today for our presentation on vulnerability management in cybersecurity. So who are we again? We are a research institute focusing on artificial intelligence and cybersecurity. You are Mark Chaplin, the UK principal at Information Security Forum, the ISF. You have over 30 years of experience in cybersecurity. And the ISF, who you work for, is a trusted not-for-profit platform that provides best practices, processes, and solutions in information security and risk management. So our aim today is to advise you that the ISF should recommend members to use machine learning algorithms to better prioritize remediation of vulnerabilities. So why are vulnerabilities a problem? As we can see clearly in this graph, the number of vulnerabilities have been increasing in the past couple of years especially. In 2018 alone, there were over 15,000 vulnerabilities, double the number of that in 2016. Clearly in the past couple of years, something has gone wrong in this industry. So let's take a closer look at the problems which a lot of industries face. To begin, we already know that a lot of assets might have a flaw. This is called a vulnerability. An attacker has a designated tool which it can then exploit this vulnerability. Then the answer currently is that of remediation, in which many cases means updating a security patch to close the security flaw. Imagine a ship which has many vulnerable points in the bottom of the ship. If these points are exploited, then the water can enter the boat, which then sinks the boat. The only way to stop the boat from sinking is to patch the points that are vulnerable. This is the same scenario. So now that we've understood the problem, we can then look at vulnerability management today. So with a growing number of vulnerabilities disclosed, as we just talked about, it is challenging for companies to prioritize one over another. As we know, the basic process of vulnerability management includes, first of all, knowing all your IT assets and networks, looking actively for problems in them, and then prioritizing them, and finally applying the solution. Our machine learning solution deals with the prioritization stage, mainly because there lays the greatest potential for machine learning, and because, as we will show, prioritization is a big problem. So to illustrate this point, we're going to use the game of whack-a-mole. Imagine instead of facing 5 holes, you have 1,000, and that at any point, any one of them could pop up a mole that you need to whack. As you only have a single hammer, how could you prioritize which one to whack first? This is the challenge which all companies are currently facing in the industry. So at the moment, the current remediation process is flawed. Basically, each vulnerability is given a score of 0 to 10. That calculates the general impacts of the vulnerability and the general easiness of exploiting it. So what's the problem? Typically, companies choose one score and that everything above this score will be patched. But the score doesn't calculate the importance of your relevant asset. And even worse, as you can see in the vulnerability distribution graph on the right, you're left with the choice of having an unimaginable to-do list or risk that you'll miss the next mega attack because your threshold was too high. And this isn't just theory. As we can see here, 2 of the most devastating cyber attacks of the last few years could have actually been avoided as the security patch was released 2 months before the attacks occurred. These are WannaCry and Petya. So the companies just miscalculated, and as the number of vulnerabilities is increasing each year, this is only going to get worse. So the industry itself also recognizes that the current solution is flawed and that there is too many vulnerabilities to cope with effectively. This came up in a Kenna Security report, in which the last point here measured that 85% of companies agree with this statement. This is their biggest problem at the moment. This is the same problem that led to the NHS losing £92 million and both FedEx and Maersk losing £300 million in the attacks outlined previously. So the solution to this problem that we propose to you today is that of machine learning. So how can machine learning help? A machine learning model can be extremely useful in classifying vulnerabilities and providing predictions about the vulnerabilities that need to be patched. As we can see here, machine learning specifically analyzes 2 different types of questions. The first one is, will this vulnerability have an exploit written for it? And the second is, will the exploit to be developed for a particular vulnerability be used in an attack? So to answer these questions, we're going to look at the technical details now of the first iteration of the machine learning model. The first iteration of the model ingests company-specific asset data, global threats, and information from vulnerability scanners as training data. However, the input data is selected based on volume and velocity of the vulnerabilities. A binary classification model, as seen in step 3, is used to generate a yes or no kind of answer. The output in step 4 is then used to predict whether an exploit will be developed for a particular software vulnerability. Then this prediction is sent to the second iteration of the model. So this second iteration of the model begins with limiting training data to vulnerabilities that have exploits. It then limits input data to vulnerabilities that are predicted to have exploits developed for them. The second iteration of the model uses a classification model. It predicts more than just a yes or no. It further narrows down and predicts if the exploit actually has chances of being used in an attack. This output is crucial to generate a risk score for the vulnerability. As we can see in the graph on the bottom, higher risk scores indicate immediate attention for patching. This significantly reduces the prioritization problem which many companies have had, as we've seen previously. So to elaborate further, what exactly is the classification model we've mentioned? This is a supervised machine learning model that draws conclusions from observed values. Specifically, in a given context, the model draws discrete conclusions from asset, threat, and vulnerability data. Equally, precision and accuracy are two crucial benchmarks for any machine learning model. In this case, precision that the exploit is correct is more valuable information for businesses than accuracy of number of vulnerabilities detected. So a question arises, why do we need a predictive risk-based, data-driven vulnerability solution when existing CVSS score-based systems suffice? The answer is to move away from manual error-prone Excel sheets, scanning towards a robust automated approach. Also, the current approach of let's just patch vulnerabilities with the CVSS score of 7 and above misses out real-time threats and thereby resulting in breaches. This was a primary reason the vulnerabilities are now double what they were 2 years ago. The current CVSS approach is flawed. So to show you the improvements that can be seen when using a machine learning solution, we've taken Cybersecurity as our use case. Although we do not promote one company going forward for any machine learning solution, we believe that Kenna is an ideal use case to examine this technology. So who is Cybersecurity? Cybersecurity is a leader in predictive cyber risk, which was founded in 2009. The most recent ML solution, which was created in 2017, is Kenna's exploit prediction. It uses machine learning to provide personalized risk prioritization. In 2017, it piloted the solution on 12 companies across various different industries. So how does the exploit prediction link to the previous technical details we just talked about? Well, the ML system mines Kenna's ground truth telemetry, which is a database of 2 billion vulnerabilities, for real-time insights on attacker behavior. Then a predictive modeling algorithm forecasts the likelihood of exploits being weaponized, and a risk scoring engine forecasts the risks of new vulnerabilities. So the use case results are particularly insightful here. First of all, exploit prediction forecasts the weaponization of new vulnerabilities with a 92% accuracy rate. Equally, 80% of Kenna's customers reduce their risk posture score by 25% or more. For example, The Economist, which is one of Kenna's customers, reduced the risk posture score by 50% since implementing it in 2018. Then moving on to the use case testimonials. So to begin with Genpact, scanning penetration reports that previously took 6 to 8 hours are now generated in 30 minutes, a reduction of 90%. Equally, they said, adopting Kenna energized the teams who were otherwise overly burdened with a seemingly endless mountain of vulnerabilities to constantly hack away at. The results are equally as good for TransUnion, who stated, "It used to take a full day to put together reporting using our old pivot table process, which we've now gotten down to a couple of hours with Kenna." We believe that these use cases and the strong statistics back the fact that machine learning is the best solution going forward for many industries and companies. So to summarize the benefits we just mentioned, we believe that ML will increase remediation efficiency and maximize remediation coverage, as we've just seen in those 2 testimonials. Equally, we would believe that redirecting human efforts to supervising and problem-solving tasks will be hugely beneficial. This will link to offer operational efficiencies and potential operating expense savings on the medium to long term. Overall, we believe that enabling greater visibility on all vulnerabilities and reducing time on consuming and complex manual inspection will be beneficial for companies. So in sum, our recommendations to you at the ISF are thus. Firstly, we believe that ML is a better tool to prioritize vulnerability in compared to alternatives. Hence, the use of machine learning algorithms should be considered positively to prioritize vulnerabilities effectively. Second, to provide input data, companies should be guided as a precondition to maximize their ability to, firstly, identify their systems and networks, and secondly, scan actively for vulnerabilities within them. Next, we believe that because of the complexity of the use of ML, it should be strongly considered that external providers would be used for the prediction stage. On the other hand, ISF should be wary not to promote one product in order to prevent monopolization of the market. Lastly, although ML is a good solution for the prioritizing problem, of course it's not a magic trick for the entire vulnerability management process. Companies still need to cope with the rest of the challenges. For example, once you prioritized, how are you going to manage the patching process itself in relation to business processes? So lastly, we believe we would be bereft of our duties if we didn't show you the possible risks that could go wrong with machine learning. So drawing your attention to the first risk scenario, lack of appropriate data input, we've labeled this as a major impact on all organizations using ML. Our mitigation measures are thus. Companies must maximize their ability to identify their systems and networks and scan actively for vulnerabilities within them. Equally, our second risk scenario that we would draw your attention to is that of decision makers disapproving the project. We rate this yet again a high impact zone. Business advantages should be clearly articulated, explaining both the high risks of unpatched systems and the alternatives as we've done so far. Finally, we'd also like to draw your attention to the possible risk of a lack of understanding of machine learning in cybersecurity. Yet again, we label the likelihood of this high and the impact high as well. It should be strongly considered that external providers would be used for this reason. On behalf of the Artificial Intelligence and Cybersecurity Research Institute, I'd like to thank you for your time, and we hope that we've made a compelling case today for you to recommend to your members to include machine learning as part of the vulnerability management. Thank you very much.